Hey there, we're going to get a little more practice doing this molar mass stuff. Molar mass, hopefully remember, it's the relationship between the number of moles of a substance you have as well as the amount of mass you have. Start simple. If we have a working mouse, if we have 6, that's not a 6. Let's actually go to the tablet. There we go. If you have 6 moles of something simple like chlorine gas, which comes as a diatomic molecule, and you want to find out how much mass you have of that. Well, we'd have to go to the periodic table. 1 mole of chlorine has number 17. It's 35.4527. If your numbers are slightly different, it's okay. But that number means that 1 mole of chlorine has 35.4527 grams. All right. Now, that's for chlorine as by itself. We have Cl2. 1 mole of Cl2 has twice that much mass, 35.4527 times 2. All right. And how do we figure that out? Just a little bit of calculation. So we have 35.4527 times 2. 70. 70.9054. 54 grams of Cl. This should be Cl2. Okay. Up here was chlorine. This here is Cl2. So 1 mole Cl2. Okay. This here is going to be what we use to solve this. Now, once we have these equations, we make our ratios. 1 mole of Cl2 per 70.9054 grams of Cl2. Am I getting any better at writing with this thing? This is a tablet I use. I'm actually drawing on a tablet, like a giant mouse pad. And it takes a little bit of getting used to. I haven't used it too much. But I can read it. Hopefully you can as well. 1 mole of Cl2. There, I've created my 2 ratios. They're not mole ratios. This is a ratio we call the molar mass. How do we know it's a molar mass? Mole mass. Now, which one do we need to solve this problem up here? Remember, we wanted to find out how much mass is in 6 moles of chlorine. So to do that, we need to find moles of Cl2 on top, moles of Cl2 on bottom. Whenever we want to go between mass and moles, we use molar mass. In this case, we take everything on top and multiply it and divide it by everything on bottom. So what we get is 6 times 70.9050. 70.9050. Zeros need some work. Divided by 1. Where's that calculator? 6 times 70.9050 divided by 1. But we don't really need to divide by 1. I just do it for the videos. 425.43. 425.43. Okay, which means up here that we have, after we cancel moles of chlorine and moles of chlorine, 425.43 in our units. And the ones we haven't canceled out, grams of Cl2. Alright, there's our answer. Let's try this again. Okay. Let's say in this problem, we start out with, how about something very small, 0.0027 grams of, let's do table salt, NaCl. Now notice in this problem over here, we start out with moles of chlorine. Here we're starting with the mass of the compound. Even though we start out with a different amount, if we want to go from moles to mass or mass to moles, it's the same process. Mass to moles, moles to mass. We use molar mass. The molar mass is, for NaCl, we have to look at our chart. Sodium, which is number 11, 22.98977. 22.98977. And there's only one sodium here. There's no subscript here, so we indicate that we assume there's one. That's a 7. Plus, whatever is for chlorine, we just did chlorine, it's number 17, 35.4527. 4527. Right. Add those together. You have a calculator at home? I hope so. It'd be kind of hard to do these if you didn't. Or I guess if you got a computer. Every one of these has this little bitty calculator here. It's awkward to use though when you're touching with a mouse or a pencil on some other weird tablet. Maybe if I didn't do so much small talk, I could use this calculator but quicker. 4527. Right, and this is 58.44247. 58.44247. Is that right? 58.44247? Yes, is it? Okay. Now, that's the molar mass. What that means is 1 mole of NaCl has 58.44247 grams. Okay. And I'll rewrite it again down here. 1 mole of NaCl. Writing this step here is very essential to complete understanding of what you're doing. You can go through the motions, you can punch in numbers in your calculator, but just because you get answers doesn't mean you actually understand what you're doing. Once you can write nice equations like this, take that equation, put it into a ratio, once you can do this, even if it takes you a while, and you look at it, and you identify the units you start with on top, grams of NaCl, and you find out the ones that have them on bottom. Not here. Grams of NaCl, grams of NaCl, grams of NaCl, grams of NaCl. Whatever's on top has to be on bottom. And once you can do that, you can tell yourself you've mastered this. But it doesn't come from watching a video. It doesn't come from watching me do it. It comes from watching, I guess, a third video and then following along and doing the problems on your own. But here we have our numbers. The grams of NaCl cancel with grams of NaCl just like we wanted. And we have 0.0027 times 1 times anything on top, divided by 58.44247. Times 1 divided by 58.44247. It's a tiny number. It's a scientific notation number. This is 4.6 times 10 to the negative fifth. Okay. Now if we put that up here, can I squeeze any more room out the side? Yeah, there we go. 4.6 times 10 to the negative fifth. And our units, moles of NaCl. I'm going to write them down here. Moles of NaCl. There we go. And that's our answer. Okay. I'm going to go create a third video now where I sit there and I do a bunch of these problems. And you can watch. You can follow along. You can predict what's going to happen. Pause the video, do them on your own. Or even you can look through, and if you get confused, rewind, all the normal stuff. At the end, I'll pose the problems, a couple problems for you guys to do. Wow. All right, I need a drink. I'll see you guys in the next video.